Hey guys, welcome back to geometry. Today we're going to take a look at something called right triangle trigonometry. Okay, now first off, let's get some of the terminology out of the way. You got a right triangle. How do I know it's a right triangle? This little guy right here. This right square in the corner tells me that that's a right angle. If there's a right angle, it's a right triangle. Now, I think we all know the longest side of that right triangle is called the hypotenuse. Now, a lot of times you'll see this abbreviated just HYP. Okay, we'll call the hypotenuse, when we're writing it, we'll write HYP. We still say hypotenuse, but we can abbreviate it while we're writing, and everyone knows what we mean. Okay, then I've got these other two sides. Now, on any right triangle, these two sides are called the legs, the two sides that form that right angle. Now, I want to give them specific names, though, and what it comes down to is this little guy. This symbol right here that looks like an O with a dash in the middle is called theta. It's a Greek letter. Okay, and we use this in trigonometry as kind of our go-to variable. The way that x or y are your go-to variables in algebra, theta and beta, okay, which is a goofy looking B, those are your go-to variables for trig. Now, which angle we call theta dictates what we're going to name these two sides. Okay, now, if I call this angle theta, this side right here, right next to it, is called the adjacent side. And a lot of times we'll abbreviate that ADJ. This side over here, not even remotely close to it, is called opposite. Okay, or a lot of times we'll abbreviate that OPP. Now, as I've said many times, mathematicians are not creative when it comes to naming things. Okay? Hypotenuse is kind of a cool, fun, mathy word, but adjacent, that just means right next to. And opposite, I think we all know what opposite means. It means really far away. That's how they're named. The opposite side is really far away from that angle. The adjacent side is part of that angle. And the hypotenuse, well, that's opposite the right angle. Now, what can happen, though, sometimes, if we want, we can switch which angle we call theta. Okay? I can call this guy up here theta instead. And if I do that, this side right next to it is now adjacent. And this side, really far away from it, is now the opposite. So which side is adjacent or opposite depends on what angle you're talking about. But the hypotenuse is always opposite the right angle. It's always going to be the longest side. Now, what's really important is that this right angle can never be your theta, can never be your beta. It always has to be just the right angle. Your theta or your beta have to be one of these two acute angles, either one of them, okay? But which angle they're talking about, that tells us what side's adjacent and what side's opposite, okay? Now, let's take a look at a couple examples. Or, sorry, before we get to the examples, how could we do the examples without this next bit? So what these ancient Greeks did is they came up with some ratios of these sides, and they called them sine, cosine, and tangent. Okay, and then down the line, someone else figured out, hey, there's some special relationships between the sides of the right triangle and that angle. So sine, if you look at your calculator, okay, right above those numbers, you see sin, cos, and tan. Those are actually abbreviations for sine, cosine, and tangent. So when we write them, we write sin, cos, and tan, but we always actually say the full word. We say sine, cosine, and tangent. Okay, don't say the abbreviation. You'll sound a lot dumber than you are. I know you're smart. Everyone needs to know you're smart from what you're saying. So say the right thing. Now, sine is opposite over hypotenuse. Okay, so if I have this angle, the opposite side divided by the hypotenuse is called the sine. The cosine is adjacent over hypotenuse. So if I have this angle, the adjacent divided by the hypotenuse is equal to the cosine. And then there's tangent. Tangent is opposite over adjacent. So if this is my angle, the opposite side divided by the adjacent side is going to be equal to the tangent of that angle. Okay? Now, we can use this to find missing sides, to find missing angle measures inside of a triangle. So let's take a look at that in action, a couple of examples. Okay, example number 1. I've got this triangle. Okay, here's my right angle. This side is 12. this side is x, this is what I want to find, and this angle here is 38 degrees. So the first thing I need to do is figure out which trig ratio I'm going to use. Okay, now that's these three. It's always going to be one of these three options, either sine, cosine, or tangent. And there's a mnemonic device, a trick that we use to remember them. Okay, it is Sohcahtoa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now there's a catch here, and this is really, really important. This trick works for right triangles only. It will not work for any triangle that's not a right triangle. We call those oblique triangles. There's other tricks that we can use. There's law of sines, law of cosines, and a whole bunch of other tricks out there as well. But Sohcahtoa, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. This is called right triangle trigonometry, and it's only used for right triangles. Now, let's look at it in action. Okay, so again, I've got this triangle. One leg is 12, this angle is 38 degrees, and this side is x. So what I want to do first is identify the angle. So I'm going to highlight that. Okay, this is the angle that I'm talking about. So I need to determine which trig ratio I have. Well, let's label these all three sides of the triangle. Okay, opposite that right angle is always the hypotenuse. Opposite the angle in question, our theta is going to be opposite. And then part of that angle is our adjacent. So I take a look at what parts of the triangle we actually have, okay, and what parts we're looking for. I have the angle, I have the adjacent side, and I want the opposite side. So I want adjacent and opposite. Now the trig ratio that puts adjacent and opposite together is tangent. Okay, so I can say the tangent of theta is equal to the opposite over the adjacent. Okay, then I'll take this and I'll sub everything that I can in. So the tangent of 38 degrees is equal to the opposite x over the adjacent 12. Okay, now next step, I want to solve for x. X is being divided by 12, so we'll multiply both sides by 12. Okay, these 12s cancel, and x is all by itself. Now what's really important here is we're not multiplying 38 times 12. We're multiplying the tangent of 38 by 12. So 12 times the tangent of 38 degrees. So we go to our calculator and we do 12 times the tangent of 38 degrees. See if you can, there we go, right there. Now, what's really, really important here, degrees are not the only way that we can measure an angle. Okay, we can also use something called Radian Measure, and the calculator is very capable of doing that. It has modes that it can do degree or radian, so we need to make sure that it's in the right mode. So, see this button right here that says Mode. Push that button, okay, and it brings up this menu. Okay, I think it's the third one down. Yep, the third one down. It has radian selected. So I need to use the arrow key and shift over to degree mode. Okay, once it's in degree mode, see above that mode button, it says quit. Okay, we'll press second, quit, and brings us back to this screen. Now we can press equals, and we get about 9.375. So x is about 9.4 is equal to x. Now, if you're using a regular scientific calculator, you'll see a button on there that says DRG. Make sure that DEG is in the bottom of your screen. That's how you know you're in degree mode. Guys, it's really important that you check that. If you're not in degree mode, you will get wrong answers and you probably won't even realize it. So make sure you're in degree mode every time you press sine, cosine, or tangent. Okay, now let's take a look at this next one. Okay, first thing I want to do is highlight this angle. Okay, then I'm going to label those sides. Okay, so this x is opposite the right angle. That makes it the hypotenuse. This 8 is opposite the angle in question. That makes it opposite. And then this side over here is called the adjacent. Okay, it's right next to that angle that we're given. So I have the opposite. I'm looking for the hypotenuse. So what I'm going to do is set up that equation. Now I need some space, so I'm going to erase some of this stuff. Okay, so I can say I want to figure out which trig ratio I'm going to use. I have the opposite and the hypotenuse. The trig ratio that puts those two together is sine. So I can say the sine of theta is equal to the opposite over the hypotenuse. Then I'll sub in everything that I have. So the sine of 16 degrees is equal to that opposite 8 over that x that we're looking for. Now, this time's a little bit tricky than last time. We're trying to find x and it's in the denominator, so I can't just multiply both sides by 8. That won't isolate x. But what I can do is turn this into a proportion. And once it's a proportion, we can cross multiply. Okay, and I'll have x times the sine of 16 degrees is equal to 8 times 1, which is 8. Now, x is being multiplied by sine of 16 degrees. Divide both sides by sine of 16 degrees. Okay, and I'll get that x equals 8 divided by the sine of 16 degrees. Now that's exact. If I want to get a decimal approximation, bring out our friendly calculator and do 8 divided by the sine of 16 degrees. And I'll make sure I'm in degree mode. Okay, good. Now you'll notice that when you press that sine button, it automatically opens up that set of parentheses. We need to make sure that we close those parentheses after that 16. Okay, press equals, and we get about 29.0. So x is approximately equal to 29.0. Okay. Now, let's take a look at one more here. Okay, example 3. Okay, first thing that I want to do is highlight the angle that we're given. Okay, so this is the 55-degree angle that we have. I have this side's x, this side's 18. I don't have anything for this third side. Well, I know opposite the right angle is going to be the hypotenuse. I know opposite the angle that we're given is called opposite. And this x that's part of that 55-degree angle, that's going to be the adjacent. So I have adjacent and hypotenuse. Okay, and the trig ratio that's going to put those two together, adjacent and hypotenuse, is cosine. Now, I'm going to need some space. Okay, so I'll say cosine of theta is equal to the adjacent over the hypotenuse. Okay, then I'll sub in everything that I have. Cosine of 55 degrees is equal to that adjacent side, x, divided by the hypotenuse of 18. Now, I want to get that x all by itself. It's being divided by 18, so I'll multiply both sides by 18. Okay, these 18s cancel, and I get x equals 18 times the cosine of 55 degrees. Okay, now that's exact. If I want to get an approximation, bring out our friendly calculator. So we do 18 times the cosine of 55 degrees. Okay, make sure that we're in degree mode every time you press that sine, cosine, or tangent button. Make sure you're in degree mode. Okay, and we get about 10.3. And there we go. So that's how we find a missing side. We can also use Sohcahtoa to find missing angle measures. Okay, now the ratios are still the same. So it's still Sohcahtoa. Sine is opposite over hypotenuse, adjacent is cosine over hypotenuse, and tangent is opposite over adjacent. But there's a slight trick, a little detail that we'll need to change. Okay, so this time, on example 4 here, I'm given this theta, this side's 34, this side's 13. Now this is still the angle that we're discussing. Okay, this is still the one that we want. Okay, so I'm still going to label my triangle based on that angle. Opposite the right angle is still going to be the hypotenuse. Opposite that given angle is still going to be opposite. And adjacent, right next to that angle, part of it is called adjacent. Okay, so the two pieces that I have are the opposite and the adjacent. And I want the trig ratio that puts those two together. Well, that's tangent. So I could say tangent of theta is equal to opposite over adjacent. And we'll sub in everything that we have. So the tangent of theta is equal to 13 over 34. Now, this time what I'm looking for is the angle. I'm not looking for an x outside on this part of this fraction. I want the angle itself. So I need to get rid of that tangent. Okay, well, if you take a close look at this calculator, right above sine, cosine, and tangent, in yellow, you can see sine to the -1, cosine to the -1, tangent to the -1. Okay, now we can use that to find the missing angles. Okay, I want to get that theta out of the tangent. That's sine to the -1, cosine to the -1, tangent to the -1. That's called the inverse sine, cosine, and tangent. So what I'm going to do to get rid of this tangent is take the inverse tangent on both sides. Okay, it's not multiplying by tangent. It's not multiplying by inverse tangent. It's taking the inverse tangent of. Okay, so on this left side, those cancel. Theta's all by itself. On the right side, I want the inverse tangent of 13 over 34. Okay, so what we're going to do, okay, we press second and then that tangent button, and if we look close, we can see it says tangent to the -1. Okay, then we'll type in 13 divided by 34, close those parentheses. Now just double check, make sure that you're in degree mode, and we get about 20.9. Okay, so that angle, theta, is approximately 20.9 degrees. Don't forget that degree symbol. Without the degree symbol, you're implying radian measure. I know it's not radian measure. You need to show me you know it's not radian measure. Next up, number 5 here. Same kind of idea. Got a triangle, got some sides, want the angle. So I'm going to highlight the angle that we're given. I'm going to highlight the sides that we're given. Okay, this side right here, opposite the right angle, is the hypotenuse. This side over here, opposite the angle in question, is called opposite. And this side right here, part of that angle theta is adjacent. So I have the adjacent and the hypotenuse. And what I want is a trig ratio that puts those two together. That's cosine. So I can say the cosine of theta is equal to the adjacent divided by the hypotenuse. Okay. Now I'm going to sub in everything I have. Okay, cosine of theta is equal to 25 divided by 32. Now, once again, I want that angle. I don't want cosine, I want the angle itself. So I'll take the inverse cosine on both sides. Okay, that's inverse cosine. So just like we did for tangent, we'll do second cosine, and it gives us cosine to the -1. That's inverse cosine. Then I type in 25 divided by 32. Press equals, and we get about 38.6. So we can say that theta is approximately 38.6 degrees. And there we go. Now let's just do one more. Okay, on this triangle, we're given this angle here and these two sides. So we need to figure out which trig ratio to use. So first off, opposite the right angle is the hypotenuse. Opposite the angle that we're given is opposite. And that last side, the one that's part of that given angle, is going to be the adjacent. So we're given the opposite and the hypotenuse. And we want a trig ratio that puts those two together. That's sine. So I can say sine of theta is equal to opposite over hypotenuse. And then we'll sub in everything that we have. So the sine of theta is going to be, the opposite is 22 divided by the hypotenuse is 34. Now, if we wanted to, we could reduce this fraction, but we really don't have to. Okay? What we do want to do is get that theta by itself. So we'll take the inverse sine on both sides. Okay, just like tangent, just like cosine, there's an inverse sine, and it's in the same place. Second sine. Okay, and we see inverse sine. Okay, and then 22 divided by 34. Close those parentheses. Double check that we're in degree mode. It's always good to check and make sure you're in degree mode. Press equals, and we get about 40.3 degrees. So theta is approximately 40.3 degrees. And there we go. So, given a right triangle, the side opposite that right angle is going to be the hypotenuse. The side opposite the given angle we call opposite. And the side right next to that given angle we call adjacent. You might be able to hear my kid screaming back there, I'm not sure. He's fine. He's just playing. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. The trick we use to remember that is Sohcahtoa. Okay, and remember, this works for right triangles only. This is my son. He was screaming. I think he wanted to be part of the video. Say, hi, Daddy students.
Hi, students.
They're learning math. Do you want to learn math?
Yeah.
Yeah, he likes math. Okay. All right, Bob. Daddy's going to finish up. All right, so to wrap things up here, if you have a right triangle, the side opposite the right angle is called the hypotenuse. The side opposite the angle that we're talking about is called the opposite. And the side that's right next to the angle that we're talking about is called the adjacent side. Sine of this angle is opposite over hypotenuse. Cosine of this angle is adjacent over hypotenuse. And tangent of this angle is opposite over adjacent. Sohcahtoa, right triangles only. Right, Bub? Yeah. Okay. All right. Thanks very much, guys. There's an assignment on Teams. Email me. Hit me with the chat feature one way or another. If you have questions, make sure you get them answered. Good luck.